This podcast is all about the science of static electricity. So, Ben, what's that?
Well, all forms of electricity involve electrons. Now, these are the negatively charged particles that surround the outside of an atom in a cloud. Static electricity is special, though, because the electrons aren't moving very much. One of the most common ways of generating static electricity is to rub two different materials together.
Like when I rub a balloon on my hair, for instance.
Yes, that's right. Some materials attract electrons more than others. For example, rubber attracts them more than your hair. So when you rub the balloon on your hair, each time a hair touches the balloon, a few electrons will move onto the balloon. As you rub the balloon, this happens thousands of times, and a charge builds up.
So what effect does that charge have?
Well, two things with the same charge will repel one another, which is why if you charge yourself up on something like a Van de Graaff generator, your hairs will repel one another, they'll repel you, so they stand up and your hair goes all over the place. And things with opposite charges attract one another.
So if I put the negatively charged balloon near to something positively charged, they should attract one another?
Yes, really quite strongly.
And what happens if you bring the charged balloon near to something uncharged?
Well, every atom, even in an uncharged object, has both positive nuclei and negative electrons. Just their numbers are balanced. Even in an insulator, these charges can move a little bit. So when you put a negatively charged balloon near an uncharged wall, for example, it will repel the electrons in the wall.
So it pushes some of the electrons out of the way and that leaves the more positively charged nuclei behind?
Yes, that's right. The area closest to the balloon becomes slightly positively charged, and that attracts the balloon, so you can actually stick a charged balloon to a wall.
Which is a very nice party trick, but where else do we find static electricity?
Well, the crackling sound you hear sometimes when you take off a nylon jumper is actually due to the jumper charging up so much that an electric current jumps across the air in the form of a spark. Sometimes you can actually see them if you undress in the dark, and sometimes they hurt.
Yes, it can be quite painful. I've had a few nylon vests in my time. Is there anywhere that static electricity can be useful, though, for things other than party tricks and pain infliction?
Well, yes, actually, we use it in photocopiers and laser printers and machines that spray paint cars. You can even use it to reduce the emissions of a power station to make it more environmentally friendly.
How does that work?
Well, smoke consists of lots of tiny particles, and in the same way as your balloon attracts the wall, an electric charge will attract the smoke particles, which makes them stick to the charged object and stops them from escaping out of the chimney.
Intriguing. So what about photocopiers? What's that got to do with static electricity?
Well, both photocopiers and laser printers use ground-up plastic powder called toner. They use that as an ink. First, a drum is charged up. The drum is made of material which will discharge if light is shone on it. So in a photocopier, an image of the document is projected onto the drum, so where the image is bright, the static charge dissipates.
So now you've got a version of the image, but built up by static charges on that drum?
Yes, that's right, and the machine then dusts the toner powder over the drum, and it only sticks to the charged parts. The drum is then pushed onto a piece of paper, and you get an image in toner on the paper.
So why doesn't the powder just rub off onto the paper?
Oh, well, at the end, the photocopy just sort of cooks the toner, and it melts and sticks together.
Ah, right, so that's why the copies come out warm. So is a laser printer similar then?
Well, this is very, very similar. In fact, it's almost identical. But instead of projecting an image of the original onto the drum, a series of lights connected to a computer illuminate it and create a pattern in the static charge.